Okay, so this is a video on differentiating trigonometric functions. You'll be able to differentiate sine and cosine functions, and you'll be able to explain why the derivatives of sine and cosine functions are what they are. Since differentiated functions tell us about the slope of a function, we'll start by analysing the slope of a sine curve at different points. If we map the gradients values to another graph, once we've plotted all these values, we'll be able to draw a curve and see what sort of shape we've got. And what we end up with is a slightly wobbly cosine function. From looking at the graphs, we can say that the derivative of a sine function is a cosine function. So let's check if that's right. We're going to check it with n-deriv on our GDCs. So the way this works is you put in n-deriv and then in brackets the function you want to differentiate, and then you set the variable equal to some point. In this case, we're going to look at the point pi by 4. On the next line, we'll type in cos of pi by 4, and we should find that the answers to these two is equal. You should check this for other values of x. We've now found and confirmed that if fx is equal to sine x, then the derivative is f dash cos x. Let's put that in a blue box because it's important. Let's have a look at what happens to the sine function when we differentiate it. So the sine function has been transformed in the x direction. It's been, if we have a look, it's been moved to the left by a factor of pi by 2. So we can say here that cos x is sine x plus pi by 2. So if cos x is sine x plus pi by 2, then the derivative of sine x is sine x plus pi by 2, which is equal to cos x. So we can infer from this that if fx is equal to cos x, then the differential is equal to cos x plus pi by 2. If you check that on your GDC, you'll see that cos x plus pi by 2 is equal to minus sine x. Sticking with our GDCs, we're going to check that the derivative of cos x is minus sine x. So using the n-deriv function, we check the point pi by 4, and I would encourage you to check other x values. If they're equal, then the functions match. If fx equals cos x, then the derivative is minus sine x. And again, it's important, so it goes in a box. Now what we're going to do is look at some worked examples. So if there's anything you haven't understood up till this point, then go back and watch it on the video, look at it in your maths book, look it up on the internet. For the worked examples, look at the question, pause the video, try and do it yourself. If you get stuck, press play for the explanation. Our first example, we're going to differentiate this function. fx equals 3 sine x minus 4 cos x. So we start off writing that f dash x is 3 times the derivative of sine x minus 4 times the derivative of cos x. If you're unsure about this, check back in the last chapter and have a look at the differentiation rules. The derivative of sine x is cos x, and the derivative of cos x is minus sine x, which gives us 3 cos x plus 4 sine x. Our next example, we're going to find the tangent of cos x at the point x equals 5 pi by 6. Remember, we're looking for the tangent. We're given the x value, so the first thing we're going to do is find the y value. It's minus root 3 over 2, so we have x and y coordinates. Next, we differentiate the function to find the gradient. We're differentiating it at the x position 5 pi by 6, we get minus a half. Our tangent line should fit to the equation y equals mx plus c. So at this position we have y values, we have x values, we have m values, we just need to find the c. We plug this in and c comes out as 5 pi by 12 minus root 3 over 2. We can then write y equals minus a half x plus 5 pi by 12 minus root 3 over 2. That's the end of this video on differentiating trigonometric functions. I hope you found it useful.